On February 6, 2023, a magnitude 7.8 earthquake struck Turkey and Syria, killing more than 50,000 people. On February 23rd, a magnitude 7.2 earthquake occurred in border Tajikistan and Xinjiang, China. This has pushed the earthquake prediction to a hot topic again, and the earthquake clock is just the most controversial method. It has been described as metaphysics or pseudoscience by some people. But contrasting movements and clouds in the sky are related. This time, let's explore whether earthquake clouds are scientific or not. Can you predict earthquakes in fact? Clouds are formed when atmosphere is oversaturated with steam and water molecules gather around the concrete nodule in the air to condense into water droplets and ice crystals that scatter sunlight in all directions, and the force on it determines its shape. The earthquakes affect cloud formation. Earthquake clouds have long been considered as pseudoscience because seismologists and meteorologists cannot explain the essential connection between earthquakes and clouds. This is the internal structure of the Earth, and earthquakes occur mainly on crustal faults. Now, where does the energy released by earthquake come from? Most seismologists will try to explain this with elastic rebound and fault-locking theories, but they're unproven and unsubstantiated, and they cannot explain many pre-earthquake anomalies. Professor Zeng Zuoxun, a Chinese geologist, and his team proposed a combined model of seismic source cavity and launching fault after observation and study, the source cavity for short. The upwelling as the atmosphere material is pushed into weak physical space of crust by temperature and pressure differences, forming a cavity, and as temperature rises, the rock inside the cavity melts, and the pressure inside the cavity rises. This process continues until the difference between pressure in the cavity and the pressure in the overlying crust of the rock reaches a critical value sufficient to destroy the rock at its edge or top, where it emits a breakup fault. An earthquake is triggered. It's a bit like people that has been dormant for a long time suddenly bursting, but the flow and transformation of materials and the battle force have been brilliant and dark for a long time. There are a large amount of highly compressed gases inside the Earth. Before or during earthquakes, anomalous speed and release of energy from source cavity can cause massive venting from Earth crust. High temperature and high humidity gases reach its atmosphere and form earthquake clouds in different shapes under effect of temperature gradients, which are also called venting earthquake clouds. This is a venting cloud for an earthquake that hit Nepal on April 25, 2015, with a magnitude of 8.2. Many times per earthquake venting clouds have been observed. Although what we're talking about now is deduction based on observations, scientists are presenting further evidence that venting cloud is reliable. This is chromium, a metal source substance. Besides clouds, crustal zones also form haze under certain climate conditions. China's material scientist and engineer Shen Zhiwei and his team find chromium and lactate haze particles. Its presence cannot be explained by other causes of haze. The only thing makes sense is that it's released by Earth crust, which further justifies the seismic cavity model. Formation of venting clouds confirms the connection between earthquakes and clouds, and affirms the value of earthquake clouds. It's one of the earthquake clouds, but there are many odd-shaped clouds called earthquake clouds. In 2021, Professor Zeng Zuoxun redefined earthquake clouds. Earthquake clouds are clouds formed by physical field acting on water vapor emitted from the Earth, which have certain morphological characteristics and can be used to predict earthquakes. Rationalize round-shaped earthquake clouds and expands the observation to sunlight. Here's the rain sunlight cloud image of the earthquake occurred on October 25, 2019, off the western coast of Australia. And here's the picture earthquake cloud taken by netizens in Mianyang. They look similar. And this is a magnetic field. Surprise! Actually, the shape earthquake cloud is defined by waves, but not the seismic shear or longitudinal wave, which reaches ground instantaneously during earthquake. Absolutely, they cannot be used in predictions. It's a gravity wave and magnetic force wave from the source cavity generated before and during earthquake. How did it come about? When a source cavity enters ultra-high pressure critical state, many signals are released. One is a mechanical wave generated by expansion and contraction, which slowly shakes the ground, and the atmosphere receives infrasonic wave and gravity wave. Another is geoelectric signals that can be measured by ultra-low frequency geoelectric instruments, as well as geomagnetics. Chen Jiehong and his team have detected ultra-low frequency ground vertical vibrations more than once for earthquakes. What we talked about in the first paper, Earth System Science Research on Earthquake Mechanisms and Prediction Practice, and some scientific teams' research results. Of course, it's a very complex practical operation to predict earthquakes with earthquake clouds accurately. Whether it's to find them through the path of particle or to find location source cavity through magnetic gravity waves embodied by a unique mythology of seismic cloud, is feasible theoretically but difficult to operate practically, as a large number of observations, experiments, and calculations are involved. A climate superposition have to be taken into account. More strictly, the formation of seismic cloud requires water vapor as specific waves, which are not all earthquakes are able to provide. And the shape of the cloud is affected by many kinds of waves, and they all have potential to shake out clouds in that form. It's hard to identify. Similar to the three-body problem, earthquakes are in a complex motion. Many per-earthquake anomalies like anomalous seawater warming jumps are associated with per-earthquake heat outflow. The calculation of heat source can play a key role in earthquake prediction, and scientists have been searching for its laws. Although it's difficult to predict earthquake by earthquake clouds, we still have great expectations. Predicting earthquakes has been something we've tried to do since Zhang Heng invented seismograph in 132 AD. If one day we could look up and find clues to earthquakes, many tragedies would be avoided. Thank you for watching. Please hit the like and subscribe button if you enjoy it.